Hello everyone. In our lecture series, we are discussing different topic. In this direction, today we are going to discuss the topic of electrochemical sensors using the nanomaterials. So there are different nanomaterial we are applying for the electrochemical sensor. How this nanomaterial are playing important role to effective determination of for the selective detection of various various molecules. So if we're going to the discuss about the electrochemical sensors, so why it is needed? Because our body has several biological important molecule, and each this molecule playing a significant role in our metabolic activities. Suppose if any alteration either increase or decrease their concentration lead to health complications, several health complications will occur. So therefore, the selective and accurate determination of this biomolecule available in our body is very important for the clinical point of view. Apart from, there are different type of chemicals we have to investigate, or we have to detect the accurate level. For example, if we take in the water sample, there are n type of pollutant molecules or small molecules has been appeared in our water molecules in our water ecosystems. For example, phenolic it is highly carcinogenic chemical. So we have to detect this pollutant chemical by simple and effective approach. Similarly, there are different adulteration of the food. Recently, there are adulteration has been growing rapidly. So there are different type of adulteration additive has been mixed our food. So in order to monitor all kind of biological things or environmental or food related or forensic application, there are different type of things we have to detect, yeah, some kind of molecule. Those molecule either will play important role in clinical applications, or it may play important role in environmental toxic pollution, or it may play a role in food contamination or food toxin. So there are different type of molecule we have to detect by using a approach. So currently there are different method we are applying for the for the determination of these several molecules. Here I will show. For example, this spectrophotometry, titrimetry, chromatography, fluorometry, and the electrochemical methods. So these are the methods like spectrophotometry, titrimetry, chromatography, fluorometry. These are the common method has been broadly utilized for the detection of various type of analyte molecule for the effective accurate determination of their concentration. But the major drawback of this conventional technique, it is time consuming process and record a large volume of sample, and also before analyzing the sample we need a complicated pre-treatment process. And also this these instruments are highly expensive and need a skilled person to operate this kind of instrument. However, the main advantage of this instrument is it is a highly sensitive instrument. So most of the analyte can at present can be detected by the this kind of material. Among the method the past few years, the electrochemical approach are widely used for the detection of various analyte molecule in biological or environmental or food related toxins. There are n number of molecule we can approach the electrochemical technique. So when compared to this technique, the electrochemical technique has a more advantage. For example, less time consuming for the detection, because the electrochemical detection is very rapid and require a very less than minute to detect this any analyte. So the further the instrument cost is very low cost. Further advantage, it is a high selective and sensitive detection even in presence of mixed samples. So the main principle of the sensor is to accurately monitor the or to accurate determination of analyte molecule from mixture of compound. So this is the main sensor definitions. So in this direction, this electrochemical sensor has high selectivity and sensitivity. Simple procedure to analyze the electrochemical technique. In some case, we can directly there is no need of much complicated process for the sample preparation. Directly we can incorporate or directly we can add the our that real samples. So for example, even without any pre-treatment process, directly add the blood. For example, best example is here our commercially using glucometer. So without any pre-treatment process, simply we add into the we, we are adding a 1 drop of blood over the that glucose strip and insert into the meter. We will get a accurate glucose level. So similar way, the electrochemical approach has a most advantage. Currently, there are in number of devices are commercially available based on this electrochemical technique. So the electrochemical technique has a high scope. So currently, we can solve the many issue based on this electrochemical technique. So this is the electrochemical sensor. Here in this electrochemical sensor, it is composed of different component. For example, transducer is here based on the electrochemical parameter and electrochemical input. Finally, the transducer releasing the measurable electrochemical signal in the form of based on current, voltage, or resistance. So another thing is receptor. This is the analyze. The receptor tailoring of the receptor. Here transducer over the transducer we are modified or we are putting the some material or biological substrate which is called a receptor. So the receptor should be highly sensitive or specific to the particular analyte. So the tailoring of the modified electrode is a highly important. So there are different type of nanomaterial has been used for the various type of sensors. So the nanomaterial role main important for the effective determination of this particular analyte molecule. So the receptor here we can use for the some enzyme or DNA or aptamer or protein. Similarly, the receptor can be also used as a nanomaterial. There are variety of nanomaterial we are applying. So the role of these two components in the sensor is transmit the signal without any amplification from selective component or forming the change reaction. So this is the definition for the electrochemical sensor. This is the schematic structure for the electrochemical sensors. So here what are the currently facing the electrochemical sensor? Because the electrochemical sensor we have to use some conducting substrate as a electrode which is called as a bare electrode. Here bare electrode means without modifying any bioreceptor layer or without modifying any material. So what will happen when applying a bare electrode for the detection of some biomolecule or some toxic chemical or some metal ion or some food related additive or adulterant, what will happen? So bare electrode commonly we are using gold electrode, classic carbon electrode or platinum electrode. Usually the bare electrode the electrode surface in most commonly it is a spherical structure. In some case we can use it as a flat surface also we can use it as a working electrode. So the bare electrode, what will happen if without modifying or without tailoring the working electrode, if we use to detect the sensor component, what will happen? It is occur a different issues like surface fouling. For example, if we want to oxidize some phenolic based compound, for example, dopamine or bisphenol, what will happen? When oxidizing the first reaction, it can be clearly oxidize the bisphenol 2 into the corresponding derivative compound. Whereas in the second oxidation, the oxidized product completely cover over the electrode surface. What will happen? So the oxidized product completely cover the electrode surface. The electrode surface will become a inactive or non-conducting property. So that working electrode surface is not available for the further electrochemical oxidation of some phenolic compound or some analyte molecule, which is called a surface fouling. So surface fouling means when doing the electrooxidation reaction, the oxidized product deposited over the electrode surface, then the electrode, the highly conducting electrode substrate became a insulating characteristic. So what will happen if it is changed into the insulating characteristic when applying either voltage or current or resistance, or so we cannot pass through the electrode surface. The electrode surface, it will be inactive, so the electrode cannot use for the further oxidation of any analyte. So this is the main drawback when use any conducting substrate electrode without any modification, which is called surface fouling. Another main factor is here sludge electron transfer. For example, some simple molecule, the redox reaction, oxidation reaction, electron transfer reaction is a symbol, so we can easily oxidize the formed byproduct also may dissolve or it may produce gas, then does not affect the surface fouling. The electro reaction will be simple, so it can be perfectly work on the electro surface. But in our case, all the molecule we cannot expect as a simple molecule. Most of the molecule it may complicated complex molecule. So the electro oxidation reaction, it will involve 2 or 3 steps or complicated oxidation steps. So what will happen? The reaction sludge is electron transfer. It is not a simple oxidation reaction, and also with that there are different intermediate level. So if we use some macromolecule, some not, we cannot say macromolecule, some large size of molecule, it has a different functional group. What will happen? The electron oxidation reaction will be the complicated. So hence, those kind of mixed or complicated electrooxidation reaction, the barrel electrode is not suitable because it cannot be deliver or it cannot be efficiently oxidize the particular analyte molecule when it has a mixed oxidation state. Further, the barrel electrode has a less sensitive because the barrel electrode has a normal surface area, so it can be interact with only the particular number of analyte molecule. So it can produce or it can be work only the high concentration. When we go to the low concentration, what will happen? The measurable signal we cannot identify. So maybe very weak signal we cannot note down or we cannot check the things. So the barrel electrode has a less sensitivity. Further, the major drawback from this barrel electrode, it has a poor selectivity. So selectivity means here, for example, we want to detect analyte only A. So in the real sample, we cannot expect that analyte molecule has only A because the real sample has combination of different analyte molecules. So our aim to detect only the molecule A in the real sample. So, but originally the real molecule sample has A and also the other analyte molecule like B, C, D, E, F. So we want to detect only the A from the mixture of the various analyte molecule. So what will happen when we use bare electrode? It produces a poor selectivity. So it can be the oxidation or redox property of the A is severely affected in presence of other analyte molecule like B, C, D in the real samples. So when using bare electrode for the small reaction, it may perfectly work in the laboratory sample. So in the same electrode, if we bring into the our real analysis with the real sample, what will happen? The bare electrode does not effective oxidize the our desired analyte molecule in the real samples. Hence, the bare electrode difficult to use for all the electrochemical sensor for the detection of various molecules. Hence, what will happen in order to solve this issue? Then they are using a modified electrode surface. What will happen? Which is called modified surface. The electrode has been modified with some component. For example, the electrode can be modified with some biomolecules like DNA, aptamer, enzyme, or protein. We can modify anything. Similarly, we can modify with some nanomaterial like carbon nanotubes, some conducting substrate like carbon nanotube and conducting polymers, either polyaniline or polypyrrole, and some noble metal nanoparticle like gold nanoparticles, platinum nanoparticle, silver nanoparticle. Then transition metal based oxide like copper oxide, nickel oxide. There are n number of metal oxide and the sulfide and then phosphide compound. So metal oxide, metal phosphide. So there are different nanomaterial we can modify, but we have to choose the nanomaterial very carefully for the selective detection of our particular analyte, because all the nanomaterial cannot work for all the sensors. So each nanomaterial has a specific characteristic, specific property. So what will happen when modifying with the nanomaterial? So the nanomaterial playing a very play an important role to improve the high sensitivity, good selectivity, no fouling of it, fast electron transfer. Because the nanomaterial has high surface area, it has a good electrical conductivity and electrocatalytic property, because the nanomaterial has some redox center or redox active area to effective oxidation, to effective determination of some particular analyte. So in this lecture series, we will see the different kind of nanomaterial, how we can prepare and can be modified over the electrode surface, or we can call this a transducer surface, as a sensing platform for the detection of or electro-oxidation of various compound. So this electrochemical oxidation or the electrochemical sensor is a major role or playing an important analytical approach for the effective detection of various analyte. So here the modified electrode is a key component for determining the to confirm the effective working nature of any sensor. For example, this modified electrode, how it will happen, because the molecule electrode, if it has a large surface area, what will happen? The analyte molecule has been absorbed over the modified electrode surface area high amount when compared to bare electrode. Whereas bare electrode, if we assume the bare electrode has absorbed only 10 analyte molecule, whereas the modified electrode have high surface area compared to bare electrode. So here it can be absorbed maybe here 10 means here it may be 50 molecules. So what will happen? The reaction will be enhanced. Further, what will happen here when applying either voltage or current, the molecule will be oxidized. So the corresponding electron efficiently transfer from the surface to electrode. So we can get a clear signal even at a very low concentration. This is the beauty of nanomaterial when used as a sensing platform over the transducer surface. When analyte molecule interact with a nanomaterial modified surface, it can be oxidized. The oxidized electron effectively, without any struggle or without any effect, it can be completely transferred through the transducer surface, and we can detect a clearer signal even at a very low concentration. Whereas here what will happen, even if it is high concentration, when applying either voltage or current, the molecule has been involved in redox reaction, that the electron has been transferred to from the surface to the through the transducer. What will happen if any surface fouling happen? Because of this bare electrode does not highly active. So what will happen if any surface fouling happen? The electron cannot be transferred effectively through the transducer surface. So we cannot get any proper response, or we may get some weak response. Hence, the bare electrode is not suitable for the effective selective detection of the any analyte molecule. Hence, there are we can found there are n number of application or n number of report has been used some nanomaterial as a sensing platform or modifier for the detection of various analyte molecule. So in this lecture series, we will check the what are the nanomaterial we can apply for the electrochemical sensor. For example, the nanomaterial we can classify 0-dimensional, 1-dimensional, and 3-dimensional nanomaterial. There are different nanomaterial like carbon-based nanomaterial. If you take fullerene, graphene, and carbon nanotubes. Similarly, that there are different type of 2D medium, maxine, and metal based compounds. So we further the different type of transition metal and transition metal oxide, because this nanomaterial not only useful for the electrochemical sensor applications, and also it can be applied for the various applications like biomedical, battery, thermistic, photovoltaic cell, photocatalysis, drug delivery, optoelectronic, because of the unique property of the nanomaterial. Because the nanomaterial provide a special chemical and physical property. This property will be useful for the enhance the performance of the any device. So here we will see the especially we are focusing the inorganic based material preparation, how it will be influence or will affect the sensing performance. Further here main things the nanomaterial preparation, for example if we take some nanomaterial, for example here copper oxide, means the synthesis process of copper oxide is highly depend or highly sensitive based on the parameter. So when changing the parameter like synthesis condition, the property of the nanomaterial also we can tune. So the synthesis condition also major playing role for the effective detection of the any analyte. So and then this synthesis condition also when changing the condition, changing the precursor or changing the some solvent nature or changing the some surfactant property of the the surface morphology of the property are also significantly altered. So the morphology of the product also major role to get the high sensitivity of the detections. So here the so in this direction, we are going to see the first two things, transition metal chalcogenides, or we can simply call it transition metal sulfide. So this is the MX2. This is the general formula MX2 or MX. Here M refer to the transition metal atoms. So in the name of group from 4 to 7, it is a different. For example, iron, copper, nickel, molybdenum, titanium, copper, tungsten. There are different type of transition metal we can apply in this formula. Similarly, X refer to the sulfide, selenide and telluride. For example, here instead of M, if you choose a copper, X if I choose sulfide, which is called a copper sulfide. So the copper sulfide may be from CuS or CuS2 also. This is a general formula. So mixed base also may be formed. For example, Cu copper is 1.5, S is 0.5, like that mixed composition also may possible to form. So compared to this metal oxide, this metal sulfide or metal selenide or metal telluride, which is called a metal chalcogenase. Chalcogenase has a attractive property, has a special advantage compared to the metal oxide, conventional metal oxide. So why this here? Because this metal chalcogenide, it has a special characteristic like good catalytic property, good conductivity, and it can be a highly stable for the long-term application. Hence, this copper or this metal chalcogenide compound has been effectively utilized for the various applications, like for example, fuel cell. Currently, the fuel cell, most commonly the commercial fuel cell, we are using the well-known standard catalyst like platinum or iridium based or ruthenium based or nickel cobalt. So the standard catalyst has a certain limitation. Even it provide a high output or high performance. However, the cost of the standard catalyst limit their application for the broad range of usage. Hence, there are alternative electrocatalysts they are finding continuously to replace the conventional catalyst. Similarly, this metal chalcogenides broadly used for the fuel cell application because of the unique property. Similarly, this metal chalcogenides can be applied even water splitting applications also because of the high catalytic active sites in this metal chalcogenides. For example, water splitting means it can be the catalyst should high performance catalyst. So then only it can be effectively split the water into hydrogen and oxygen. Similarly, this compound can also utilize for the lithium ion battery and then energy storage application. For example, supercapacitor, because the material has a high surface area and also good redox property, and it can act as a both pseudo and capacitive characteristics based on the material choosing the transition metal as well as morphology of the product. We can use as a energy storage application, and also solar cell application, because solar cell it can be effectively absorb energy from the our solar, then it convert into a energy. This is a simple concept of the solar cell device. So this the transition metal based compound also can be used as a solar cell application. Because why this material particularly interested or will give has given a good performance in various electrochemical related applications like solar cell, fuel cell, electrochemical water splitting, electrochemical energy storage, and energy conversion application. Because of this metal chalcogenide has a very attractive property in various applications, because the synthesis conditions also we can perform through our simple synthesis method. Does not require any sophisticated or any higher end model to fabricate this metal sulfide or selenide. For example, if we want to prepare only copper sulfide, mean just if we use some copper precursor like copper nitrate or copper chloride or copper sulfate, mix with in solution, a particular solution. For example, if you want to prepare sulfide, we can use a sulfide source. There are different type of sulfur source was available for the making of metal sulfide compound. For example, the main sulfur source is a thiourea. It is a very cheap and cost effective sulfur source, and also we can use a other sulfur source like thioacetamide. This is one of the major sulfur source for this preparation of this metal sulfide compound. And then we can also use thiourea and thioacetamide, even pure sulfur powder also we can utilize for the metal metal sulfide. So these are the common precursors we are using for the preparation of metal sulfide. Similarly, selenide powder we can directly use. Here also telluride powder. Similarly, we can use a sulfide powder. So for example, here I am taking a copper chloride as a copper precursor. Sulfide powder is a sulfide precursor. When mixing into the solution, when applying some particular temperature or pressure or particular treatment, what will happen? Both will react with copper and sulfur to form a copper sulfide. So here the copper sulfate has a particular characteristic. So when changing the ratio of copper and sulfur, what will happen? We will get a different crystal structure, different composition of a copper sulfur. So based on this composition formation, we can easily tune the conductivity nature of the compound. So these are the main advantage for this metal sulfate preparation. Similarly, we can tune the different metal sulfate. For example, see here, this is the general formula of the CuSSY. So here synthetic name is covalent copper sulfate in material form, which is called CuTS, chalcosite. So this is the different composition of this copper sulfate, CuS4, CuS3, CuS4, SS. This is a structure classification. So the low alkalinate monoclinic and hexagonal, cubic, and then anhydride. These are the different composition or crystal structure of this copper sulfate. So what will happen when changing the reaction or experimental condition? We will tune the what kind of copper sulfate we are going to achieve. So when changing this composition, what will happen when sulfur low and copper rich means the material has a good conductivity. So in order to reduce the conductivity means if decrease the copper content, if increase the sulfur, what will happen? Automatically the conductivity moderately reduced and the sulfur content will be high. So here based on the composition changing, we can easily tune the conductivity property of this particular material, because some catalytic or energy storage and conversion application we need a mixed property, because only conductivity is not only confirm the property will the material will give you a good performance. So the any material it has a combination of mixed property, like it should be a moderate conductivity, it should be a surface area, it should be active site, it should be a good catalytic property, it should be a uh, hydrophobicity. Like that, there are different parameters involving to provide a good performance for the various electrocatalytic application. So for example, in the following lecture series, we will see the how we can prepare the simple copper sulfate by simple approach, and it can be utilized for the effective utilization of this as prepared copper sulfate material for the electrocatalyst application and also electrochemical sensor application in the following lecture series. So thank you.